Hey guys, welcome to another episode of me trying to learn C. In case you don't know what is happening or you don't know how I'm going to achieve that, basically I asked ChatGPT for 50 programs to create in C. So far I've done 15. Here they are. So far I've done 15. I'm going to continue from number 16, which is sorting. So in this episode I am going to sort an array using bubble sort, selection sort, and insertion sort. So let's get on with it. So I'm going to open my C tutorial folder, and inside how I do this is for each project, for each program, I create a separate directory. So I'm going to do that. So we come sorting, cd sorting, then this is my main file. So let me create my main function, 0 and not 0. So I'm going to have three functions, each one doing one of the searches: bubble, selection, and insertion. Let me write it down here. Sort array using bubble, selection, and insertion. You sort an array using bubble, selection, and insertion. So we come, then we come bubble, then selection, insertion. So how it is going to work: each function, each of them, each of the sorting functions would take in an array and then array of integers and then sort it. So take in of int. Alright, so we come here, take in a parameter which is int, a number array. This is how you do this. And then let me just copy it, then copy, num array. So beginning with the first one, which is bubble sort. So let me just give it an array. So let's go int array is equal to 1 comma 2 comma, let's go 1 comma 5 comma 7 comma 2 comma 10 comma 8. So let me print, this should print out a sorted array of the above, which is 1 comma 2 comma 5 comma 7 comma 8 comma, let's change this to 10. So we come, just to make this a bit clearer, results, this is my result. So let me check in bubble sort. That's the first one. Yeah, bubble sort. Okay, Wikipedia. I actually enjoy going to Wikipedia. It's great. Sorry about that. it is acting up. Sorry about that. Okay. Bubble sort is a simple sorting algorithm that repeatedly steps through the input list element by element, comparing the current element with one after it, swapping their values if needed. This passes through the list. This passes through the list. These are repeated until no swaps have to be performed during a pass. Alright. So this is how it works. So it goes through the list. If this is bigger than this, it swaps. Else, move on to the next. Okay. Alright, without down here we have, I think, yes, this is the pseudocode on creating it, but without looking at this, I am going to try and implement it. I'm going to try and implement this. Alright, so first we need to get the length of the array, maybe to know how many times to go over the loop. And I think I might be wrong. I am going to try and use for loop, but I think it would be better. Maybe I might try using a while loop, but right now I am going to use a for loop. So this is actually a pointer to the array. That is the length. Then you go for I is equal to 0. I is less than the length. I plus plus. Then we check if, then you now check, that's the first element. I check if the number of the array at position I, the element at position I, is greater than the element at position I plus 1. What is so? And come here, initialize a temporary variable to store. So if the if the element if okay, if it is greater, then you come temp would be equal to num array at I, then num array at position I would be equal to whatever the element is at I plus 1, then at I plus 1 would be equal to temp. Then you go else, continue. Wait, I don't think I even need this else. So for now, let's see what happens when we do this. So let me just print the whole shebang. So let's go. Then go %. .phd. Add that. So let's see what this, let's see what we get. 1527. Okay. I'm coming. Let me just copy this here so I can see it. All right. So we have this array. So we come, this is the first element with, let me get the, all right, this is the unsorted. So we come, we go through if I, the element, if 1 is less than 5, if 1 is greater than 5, you swap them. So how do you do the swap? Store 1 inside a temporary variable, then that position where 1 used to be would be this 5, whatever this is, and then the new position would be equal to whatever is in the temporary position. Okay, now this is for when I is equal to 0, and then you go when I is equal to 1, when I is equal to 1, go when I is equal to 1, then repeat the same thing. You check 1 and 2, then when I is equal to 2, you do this too. When I is equal to 3, you do this. Also, you do this. When I equals to 5, you do this. Wait, let me see. 1527. 15. So let me try this. 1527. 15278 is less than or equal to, is that right? 1527810. Okay, I think I've got it, but not completely. So what happened now is that the first, everything happened correctly, but this is the first go through, this is the first pass of the array. So I now, the next objective is to find a way to call this again, like recursively, until it is sorted. So how I can do that, I'm thinking of introducing a new variable that whenever this if statement is run, something happened. I'm coming. Let me just run it and you see. So let's go. Then go boolean. was weird. Why did that happen? Oh my god. Alright, I think I am back now. Okay, I think I am okay. I am good to go. So we go int sort, not int, sorry, boolean sorted is equals false. So we can go if it is not sorted, run this. But how would we know? Okay, here I can just do continue, so it jumps to the next iteration. So here I can do else sorted is, but wait, would this, no, this is wrong, because what if it's not actually sorted? And no, this is wrong. This wouldn't work. I need to find a way to know if it is sorted. Then I encapsulate this in a while loop. So you can go while not sorted, go ATD. So while not sorted, I'm trying to think of a way to keep it running over and over again, and then only stop when it is sorted. How do we know if it is sorted? That's if no swap was made. So I need to find a way. So I need to find a way to make it. I need to find a way to be able to know whether a swap was made in this whole iteration. So let me just try this. Sorted. Sorted is equals false. Else sorted. I doubt this will work, but let me just try it and see. 1 2 5 7 8 10, the same result as above, so nothing changed. What if I remove this? Let me see. Let me see what will happen now. Will it run infinitely? Oh my god. 1257. Okay, look at something. Ah, this is amazing. So it ran infinitely, but then it was sorted. So I think that's the only bit that is left. I need to find a way to know when the array is sorted, because here I have, this is my answer: 1257, 8, 10. So how do I change this so that I only get through? I am thinking. Sorry about that. If, all right, I've got these bits correct. Oh my God, why is this so hard? It's, I chew my finger when I am thinking. I've always been like that. But while not sorted, sorted would be equal to false. Boolean. So while not sorted. So let me try something. So we can just come here. So if I have this up here, so if I have this inside here, so if by any chance, this, let me change it to a boolean, which is actually better. Bool swapped is equal to false. So if by any chance this if statement is triggered, swapped should be equal to true. Swapped should be equal to true. Then we come here, which is we go outside the for loop and go, let's see, if swapped, if not swapped, then we can go if no swap happen at all. If no swap happen at all, then we can change sorted to be equal to true. I think this would work, so I have to try it out. This looks very messy. I don't think this is how Wikipedia did theirs, but you know, it is what it is. So let me come outside the while loop and print the array. What is this for? And then for int I j. I can even use int I reckon. I is less than or equal to length I plus plus printf percentage d comma number array at I. Let me remove this. Moment of truth. CC main.c. It worked. Come on, let's go. Let's go, puppy. Huh? Let me check how they did this. Then get the length. Then you spit. Repeat. Then swapped is equal to false. I swear to God, someone would think I copied them, but what? This looks so similar. For I to end my inclusive do, until not swapped. Oh, so what I'm thinking, I can even eliminate this sorted. I can eliminate this sorted and just use swap. Or I can even use the sorted. I think I can do this. I don't know why not think of it. I just do. Maybe while not sorted, then false. Then if nah, I better leave it like this. This works. Just try it out one more time. Ah, it's so satisfying. Oh my god, man. What what is that, bro? One, two, 5, 7, 8, 10. It works. So let me just print a new line here. A new line. This is for bubble sort. Then on to selection sort. That was actually good. My internet is kind of wacky. Bear with me. Bear with me. So let me check selection sort. Let's see how it works and how it is different from bubble sort. Selection sort is an in-place comparison sorting algorithm. The algorithm divides the input list into two parts: a sorted sublist of items, which is built from left to right at the front, and the sublist of remaining unsorted items. that occupies the rest of the list. The sorted sublist is empty, and unsorted sublist is the entire input list. The algorithm proceeds to find the smallest or the largest depending on sorting order in the unsorted sublist, exchanging it with the leftmost unsorted item, putting it in sorted order and moving the sublist boundaries one element to the right. Example: so you have this unsorted list and you have an empty list, so it takes list element so it takes the smallest element from the unsorted list. It takes it and then it adds it to the sorted list, then it now removes it, and then it checks next for the smallest, which is 12, then it gets added to the sublist and booted from here. Then the next one is 22, booted, then 64, booted. Oh, okay, this is clearer. So what is happening is, when you find the smallest element in the array, wherever it is, it should get swapped with whatever is in the list, the leftmost element. So here 11 is the smallest, you swap it with 64, then you go 12 is the smallest, after that swap it with 25, then you remove these two, like whatever is in this position, then uncheck 22, swap it with 25. Okay, without looking at the code. So let's go. I also do I need the length? So let me just get it. Length, size of a pointer to the array, then +1, so we need to get the smallest. How do you get the smallest element in an array? Okay, before that I think we need the smallest integer, then we go for int I is equal to 0, I is less than or equal to length, leng I plus plus. So we go, if the element at position I is less than, no, oh my god, so how do I do this? Oh, so what I can do, I am coming, so let me come up here. So let me just paste this here. So what I can do is, if I at first the smallest would be empty, then we go, so when we start we can just do smallest to be equal to So we assign it, the first element we see, we assign it as the smallest, then we check if it is less than the next element, nothing should happen. But in the case that it is not, then that element would be the smallest, and you continue till you get the smallest out of the list. So let me just is, so we can even do this greater than. If it is greater than the next element, then the smallest should be equal to plus 1. So if let me try and print smallest and see what we get. Smallest. So if I do this, I should get 2. So hopefully it worked. If it did, we should it did not work. Oh, I think it's because of this. So smallest num. So let me try this and see. I know why that did not work. Still it. Maybe I don't need this else bit. Oh, I'm still getting it. So smallest. So we go. If whatever the first element is number of I is greater than. Oh, wait. I think I know where I made the mistake. So here we can see the smallest. So first we assign the first element would be our smallest. So here we see if the smallest is greater than the elements, the element where the current element at position I, then that element should be our new smallest, and then we continue this. So let me try this and see. 1. Okay. Let me see. We should get 2 now if it's working. 0. Okay, there's a flaw. Why is it 0? It's not supposed to be 0. So that means it doesn't work. So we go. So let me try printing smallest here and see. 0, 3, 4, 5, 6, 6. So let me try it now. Okay, that's not G. Is equal to 0. Okay. That doesn't work. Int I is equal to 0. The first element should be our smallest. I cannot declare my smallest inside this for loop because every time the for loop is run, the smallest gets reset. I do not want that, so it has to be outside. So you can just go smallest is equal to array at 0. Five, then you have 2. And suddenly something changed. I'm coming. Let me comment this line out because I need to know what is happening. 5, 5, 2, 2, 2. Then at the last iteration. Okay. I think now it should work, hopefully. So now we get 2. Let me add my 1 back and see. Would it still be the same? Okay. And now it is not working at all. What is this witchcraft? Oh my god. Oh, I am not printing. Oh, I am not printing the smallest. My bad. My bad. 1. Now I need to make sure every element in my array is red. Then you go percentage D. If I get up to 10, 1, 5, 7, 2, 10, 1, 5, 7, 2, and 10. 1, 5, 7, 2, and 10. It is not getting. It is not reading it. 1, 5, 7, 2. Then plus 1. Like, let me check what my length is. so I need to know. So it is saying that my length is 5. 1, 2, 3, 4, 5, but it is actually 6. So if I do this, I have to do less than or equal to, less than or equal to. So now everything works. And let me remove one and see. Back to squares, back to square one. Print. So it is saying my length is 5. 1, 2, 3, 4, 5. What the heck? So I am coming. Value. So where am I getting 4 plus 1, 5? The plus 0, 5. I need to remove this. So now I am getting 4. So let me try it. So now I am getting 4 and 2. 4 and 2. So let me add my 1 back and see if 1 is the smallest. Okay, this works. So this is how it should be. I shouldn't add anything to my length, and then for my eye I just do I is less than or equal to the length. That's my for my fall. So which is this? Alright, so I have gotten my smallest. Okay, then now what I need to do is I need to get the leftmost element and the rightmost element. Sorry, I need to get the leftmost position. Its left would be, so at the beginning your left is obviously going to be equal to 0. Then you go, so after your left you're going to have temp. This is where you'll be storing your temporary variables if you're making a swap. Alright, if the smallest element, so you change the smallest and then you go, then you now after you get a new smallest, after you get your new smallest, if smallest is greater than the element, if the smallest is greater than the element, then your new smallest would be that element. If the smallest is greater than whatever you have there, so you are going to make that number your new smallest, and you change it with the leftmost. So you just do at the left is equal to the number array at I, plus plus. So you're going to increment the left position by 1. Do I even need the temporary variable? Wait, before I do that, I think I need to do temporary would be equal to whatever is in the left then whatever is in I, then numerary at I would be equal to temporary, then you increment so let me run this and see what happens. Oh my god, I am not supposed, let me just, I'm coming, I need to print out the array. One, 5, 7, 2, 10. That's not right. I'm coming. That's not right. So we need to do this. We need to run this for loop. While, I think it is while, let's say left is less than length. Then we run the for loop. So let's, oh my god, it is running indefinitely. So while, for the first one, while 0 is less than 2, 3, 4, 5, 6. I'm coming, let me print out. I don't know the way the size of function works. Size of function. It is very funny the way it works. Fine. Let's see. Let's so size. Let me try that and see. L would be equal to size of num array, size of num array at 0. I don't think this would work because I tried something like this yesterday exactly. Oh wait, I am or never mind. So I don't think this would work. This is not it. It doesn't work. Because the way this length works is very funny. I don't even know. My network is acting up. Come on. Let me do this and see. Let me check whether I can work with that arrow. This is even worse. What? I'm Just give me a minute, I'll be back shortly. Just a minute. Okay, sorry about that. This won't work. Let me just go over this. I don't need to print this. So let me just print the array. It's less than or equal to. My problem now is that this array has 1, 2, 3, 4, 5, 6 elements, and here it's saying it has 4. Come on. Or do I need to do something like, I don't know, add an ampersand? Selection, ampersand. Then here we go ampersand. Sorry. Oof. Or do I need to be, should I just get the length manually? I think I can do that, which is the most reliable. Equals 0. Then you can just do get array length. You can just do for but again I still don't know how many times to run it. Oh my god, this is messed up and my network is bad. Come on. What should I just do? I think I am supposed to, maybe I just do array of 6. 1, 2, 3, 5, 6. Maybe that will be better. Let me check. Okay. So let me just look at 1, 2, 3, 4. Number of elements. Come on. Ugh. I can hack my way through though. I can just do +1. Let me get the algorithm to work. Okay. So let me just I don't it's supposed to be here. So whenever this loop goes through, alright. Let me try this and see. Okay, still doesn't work. So this needs to be inside. Hopefully this will work. 1572108. That was the original line. If the smallest, whatever your smallest is greater than the current number, your temporary should be the current number. On your leftmost, should be the smallest. Let's see. So when your smallest is greater than the num array, the element at this position, let's say we do this. 1 is the smallest from the beginning, and if 1 is greater than 1, which is false, so this gets skipped, and your left would now be equal to 1, for the next iteration. So left would be equals 1, which is this. So we now go already from the previous iteration. 1 is the smallest, so we go if 1 is greater than 5, if 1 is greater than 5, then if 1, oh my god, let me just, come on, think. Or should we do less than? If the still the same thing. If the element at our current position is less than the smallest, then you should swap it with your smallest. Oh my god. Okay, I think I've been going about this all wrong. So I have only 2 steps. Find, I'm coming. Let me just copy them. So find the minimum element in array. Let's see, 0 to 5 because ours is 6. Find the minimum element in array 0 to 5. Place it at the beginning. Okay. So I think I can do an inner function. Smallest. It should return the smallest whenever it is called. It should take in int num array. Okay, what is equal to? I cannot define functions inside. Come on. Just 3dd. Or I can just do for I is equal to 0, I is less than or equal to length I plus plus so we can just But the thing is, if I do it this way, every time I call this function, my smallest value would get reset. So I don't think I'm supposed to do it this way. Smallest. This is surprisingly hard. Come on. Let me start all over. So you have your for loop is equals 0 is less than or equal to the length I plus plus if then that position. So this is it. Find the minimum element in the array. I think I am about to give up because this is surprisingly hard. Nothing is coming to me. Okay, let me just, all I know is at the end we're going to increment our left by 1. So find the minimum element and place it at the beginning so I can get the beginning. So now it is all about finding the minimum element. Okay, I think we're supposed to have like an inner, I'm coming. So let's go. So like an inner, so inside this inner we are going to calculate our smallest. J is equal to left, and then j is less than the length, and then j plus plus. So here we can do the number of array at 0, then if the current element that we are dealing with is greater than, is less than the smallest. So we have found our new smallest. Then we go smallest is equal to, and place it. So we have gotten our, so we now do array as left should be equal to smallest. Let me run this. Oh my god. But at least we're getting somewhere. So what is happening is this gets the smallest, or if we get the smallest and we put it there, then the smallest is supposed to change. Still the same thing. This should be left. We're supposed to do smallest or current smallest. Would this work? Smallest is 1. 1 is our current smallest. It's less than that. If whatever that element is less than 1, left plus plus, then do your, now your left is equal to 1, then I give up, man. Initialize to is length. The first element is the array to sort. Then this is the length. So is length. Then we now do for I is equal to 0, I is less than the length. And the minimum is the first element, so I've done that. Then we go into test against elements after I find the smallest. Okay. So here is supposed to be I plus 1. Yeah. So for I is equal to 0, J minimum if, so that is if the next element is less than the smallest, I am coming. Then we have found a new minimum. Alright. 1228888. If the minimum if smallest is not equal to I, where 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 they get this swap function? Oh my god. Swap function in C. The temp. So we can just do temp is equal to the num of array at I and dj minimum. Which is the smallest. Say then smallest would be equal to swap the current position of the smallest should be equal to smallest would be equal to temp. So let's see, hopefully this would work. Man, this is legit hard. Selection sort in C. Let me just find a program explaining it. Not C++, Pro, come on. This is legit hard. Harder than I anticipated. I know how it works. Selection sort. So this is it. So they created a function called swap. swap function. So when I'm done, I will look. Let me just print the array. One, two, five, 7, 10. 1, 2, 5, 7, 10. Then I will try and understand it. Okay, so this is it. So let me try and understand it real quick. So this is it. Set the first element as the minimum. Compare minimum with the second element. What I've been doing since. If the second element is smaller, assign the second element as minimum. Then compare minimum with the third element. Again, if the third element is smaller, then assign minimum. Then the process goes on until the last element. After each iteration, minimum is placed in front of the unsorted list. Okay. So this is your minimum. The first one is the minimum. Then we now go into a second for loop, and the use of this second for loop is to compare it with all the other elements, and if you get something that is smaller, boom. Okay. All right. I think I'm going to stop here for now. Maybe on my next episode I will try and do this from scratch, selection sort, and I will try and write it myself completely from scratch. Then I will do insertion sort. I think I'm going to stop here for now. We'll continue from here next episode. Thank you and bye.